example comes out of 7.4, applications of trig derivative. So for the sake of saving some space and time writing here, I've kind of just drawn the diagram without writing the big paragraph that went with it, but somebody's flying a kite. The kite is staying at a constant height of 40 meters above the ground, but it is moving out horizontally at 3 meters per second, and as the person lets out the string and the wind blows it, I guess. And we're wondering what the change in the angle d theta by dt is when s equals 80, when there's 80 meters of string let out. So we need a relationship between x and theta. We don't really want s in there because we don't have ds by dt, nor do we want ds by dt. So if we can come up with a relationship that has x and theta in it, we'll be happy. In this case, tan theta equals opposite over adjacent. That would work. Somebody else might say, oh, I don't like having x on the bottom, and do a cotangent, but this should work just fine. So if we then decide, well, let's now take the derivative of this. The derivative on this side is secant squared theta d theta by dt equals negative 40 over x squared dx by dt. That's a good situation again because we have dx by dt and we want d theta by dt. So d theta by dt is going to equal negative 40 over x squared dx by dt, and then we'll have to divide that by secant squared theta. Well, when you divide by secant squared theta, really all you do is you multiply by cosine squared. So negative 40 over x squared dx by dt times cos squared theta. Now, we don't have directly x given to us, nor do we have theta, but we do have enough information to find either one of those, in that we're told, well, first of all, that's always 40 meters above the ground, but also we're talking about the instant when s equals 80. So if I want to know what x is, I know that x squared plus 40 squared has to equal 80 squared. So if you do a little bit of those numbers there, you got x squared plus 1600 equals 6400. So x squared equals 4800. So x equals the square root of 4800. I could rationalize and fiddle with that, but I notice when I put it in here, I'm actually going to square it anyway, so no point in doing that. The same true with cosine squared theta. I could find theta, but I don't really need to because I can just say, well, cos theta is adjacent over hypotenuse. It's x over s, so it's this root 4800 I just found divided by 80. So what's my d theta by dt? D theta by dt is equal to negative 40 over the square root of 4800, but then squared, and then times dx by dt, which was 3, times the square root of 4800 over 80, and all of that again is being squared. So all my square roots end up going away. 4800 on the top, 4800 on the bottom, and even those guys end up canceling each other out since one is top, one is bottom, and you end up with an answer that is d theta by dt equals, if you're in fractions, negative 3 over 160. You could put negative 0.01875, but the units here would be radians, and the time in this one was in seconds. So negative 3 over 160 radians per second. If you picture what's going on, if that kite flies further and further out to the right, it makes sense that this angle gets smaller as, even though it is staying 40 meters above the ground, the kite's further away, the angle gets smaller and smaller and smaller. So